Hello everyone, I am Shruti Vijayargi from BISP Solution. There is another video on the Excel statistics function. So in this video I am going to tell you about the two sample hypothesis testing to compare variance. For this purpose, F-test is available in Excel for the comparison of the variances. So first, what is F-test? So F distribution can be used to test whether the variances of two populations are equal. In order to deal exclusively with the right tail of the distribution when taking ratios of sample variances from the theorem, we should put the larger variances in the numerator. In order to use this test, the following points must be noticed. Both populations are normally distributed. Both samples are drawn independently from each other. Within each sample, the observations are sampled randomly and independent of each other. If we calculate manually F test for any populations, so variances, we have to calculate first the variances for the samples, and then the F test is calculated by the division of larger variance divided by lower variances. So S1 will be our greater value variance divided by smaller variance. S2 is the smaller variance. Some I'm talking about some hypothesis test can be done. An F-test is used to test if the variances of the two populations are equal. So if the variances of the two populations are equal, then F-test is used. So this test can be a two-tailed test or a one-tailed test. The two-tailed version tests against the alternative that the variances are not equal. Okay, when the variances are not equal, then it should be a two-tailed test. The one-tailed version only tests in one direction, that is, the variances from the first population is either greater than or less than the second population variance. So if the first variance is less than the second, that means lower one-tailed test. If the first variance is greater than the small second variance, then it is upper one-tailed test. And the choice is determined by the problem. For example, if we are testing a new process, we may only be interested in knowing if the new process is less variable than the old process. So let's understand it with the help of an Excel example. A company, there's an example of a company is comparing methods for producing pipes and want to choose the methods. So these are the methods with the least variability. It has taken a sample of the lengths of the pipes using both methods. Okay, so how F-test is calculated in Excel? Just go to the data tab and then go to the data analysis tab, and from here we just see there are so many types of analysis tools. We have to go for the F-test to sample for variances and then click OK. Now the first range of the variable, that is we have to pass the array of first method. In the second variable range, we have to pass the array of the second method. And then I do select my labels of the fields, so I just check labels, and I want my output here, and then click OK. So this is the output for the F-test. So first this is the mean for both the methods. Then this is the variance. So here the variance first method variance is greater than the second variance. That means it is upper one-tailed method, and also it denotes the p-value and f critical value for the one-tailed method. So there are a number of observations. For the first method is 12, and for the second method is 15. DF degree of freedom for the first is 11 and the method second is 14, and F, this is what we actually want for this F test. So this is the result of the F test, which is 1.85 approx. And now this is the p-value for 110, which is 0.13, and F critical 2.56. So because here first we have to check F value with the F critical 110 value. If the F test value is less than the F critical value, then we do not reject our hypothesis, because F tilde here is lower than the F critical value, so we do not reject this hypothesis. And also our p value looks great, it is greater than the uh, our alpha level, which is 0.05, and so it is greater than this, so this test will not be rejected, the null hypothesis will not be rejected. So in this we have to first convert an F test. We first have to check F critical from a table of F statistics, and the degree of freedom are numerator sample of size minus 1 and denominator sample size minus 1. And if our null hypothesis F observed is larger than the F critical, then we have to reject. But in this case, F is less than F critical, so we do not reject our null hypothesis. There are some points which we do not forget about the F-test. F-test usually is a test where several parameters are invoked at once in the null hypothesis, in contrast to a t-test that concerns only one parameter. The F-test can often be considered a refinement of the more general likelihood ratio that considered as a large sample chi-square test. The F-test can be used in the special case that the error term in a regression model is normally distributed. This is in the same way as the t-test for a single parameter in a model with normally distributed data in a refinement of a more general large sample set test. The F-test can be used also for small data sets in contrast to the large sample chi-square test, but require additional assumptions of normally distributed data. So this is how F-test for comparison of variances for two samples has been done in Excel. If you have any doubts, you can ask me. Thanks for watching.